Okay, let's consider this file, few lines, and see how the importer deals with this file. You can see there is a double inclusion guard composed by the first two lines and the last line. There is the definition of some constants. There is a little bit of variability. In this case we have a variation point and some type def. Not a very complex file, but there are some different elements. Okay. Now I will use a version of the importer that it's thought to be useful during the debug sessions and during developing the tools. So it permits me to go step by step and see what happens. Okay, I just need to insert the path of the file to import, a reference to a feature model. In this case, I just created a feature model with no elements. And okay, let's reset. Now, as you can see, there are many steps, but let's start from the first. Initially, it's created a version of the file. It's a bit slow because of the recording. Okay. Okay. Initially, okay. Initially, the file is analyzed and the test is broken, considering separating the comments, the snippet of C code, and the preprocessor statements. And at each element, for each element is reported the original line in the source file and the characters. Basically, it means that this statement comes from the first line of the original file and it takes the first 30 characters. After that, I could go on the next step. In the next step, the different kind of preprocessor statements are recognized and expression are parsed. Step by step, at a certain point, I will recognize a certain step represent variation point, so I will consider the elements that are inside this variation point, and okay. At a certain point, for example, I will merge the definition of elements of the same name if some conditions are met. Without going into many details, it means that I can merge two definitions of the same symbol if between the two definitions the symbol is never used. Okay, now let's... at the last step, I have analyzed all the possible usages of the preprocessor, and I have recognized that some things correspond to constant, and they assume a certain value when some presence condition is met. And for a particular symbol of the file, there were two different values, which are given to this symbol under different conditions. So if we look at the original file, this sum constant 1 is defined to value 0 u when foo included is equal to s of, and it should be assigned to 10 unsigned when foo callbacks is equal to s of, and this is the case. There are some concepts that are not lived. In this case, this is just the code, because the code is not lived to higher level concept at this step, but it will be analyzed in the last step. Okay, a module is created, and in this case I can see that I have the definition of a constant for each symbol that was defined in the original file, but not for the symbol that I understood being features. In this case, for example, foo included and s off are used inside a variation point, as well as foo callbacks. So their define are not translated to constants, so are not present in this file, but were instead inserted in the feature model. Now, you can see that for foo included and foo callbacks, there is a default value, which is the value of the symbol s off. Well, it represents exactly what is present in the original file, so it means that if no value was assigned by the user explicitly to this symbol, at that point, in that case, the symbol will take the value of s off. You can also see that for each of these this feature was created an attribute with a name value. The importer tried to understand when probably there will be some value associated to a feature, looking at how the feature is used. In this case, for example, foo included, s off and foo callbacks are used inside equals expressions. So they are not just flags, not just something without a value associated, because if that would be the case, the expression would be simply wrong. I don't have no information to really assume what kind of actual type the user was intended, so as a default I create an attribute of type int 32. The user could later change the value if, for example, you want to associate a char or, I don't know, a float to this particular symbol. Of course, the different the different presence conditions are assigned to the define. So, for example, some const 2 is defined only when this condition is met, while some const 1 is assigned under two different conditions. So, either this condition is met or this condition is met. Therefore, the definition of some const is decorated with a presence condition containing both the two possibilities, and the actual value will depend on the configuration. In this case, this is a quite common case. I have a reference to a type that is actually not imported by this model. The problem is that frequently C files take information from the context. So that case they will take any whoint 8 or whoint 16 that happens to be defined by files before they import this particular file, this fit values h. This is an issue that the importer has to deal with. At this point we have just the importer recognizes that this type cannot be found, so decorate this missing type with this message, type not found. As a later step, types will be resolved. Okay, that's it for the first example.